Before we continue to look at the building of a layout and the representation or modelling of robotic tasks, let's first remind ourselves of what a 6-degree of freedom robot looks like. In this screen, we're going to insert from a catalogue a robot. There are robots from almost all robot manufacturers. In this case, we'll choose an ABB robot, and then we can look through the catalogue in various ways to find the robot we're after. So I'm just going to take a robot, no particular robot, let's take this ILB 2400, and we can then position that using the mouse. Let's just navigate around this and see its basic layout, its basic organisation of parts. There's a base and various joints which we can move. So I'm just going to select the robot from the tree with the jog mechanism, and we can see 6 joints here. This is a 6-degree of freedom robot. It can rotate in 6 different ways in this case. All of the movements in this case are rotational, which is quite common for many industrial robots. There's the elbow, and then we come to the 3 movements on the wrist of the robot. You'll notice they have human type names, anthropomorphic names, and we can move these again. We can move them just like we did with the building of the peg welder by dragging the joint axis. Each of these joints is essentially a mechanism in the same way that the peg welder was. As well as moving the joints through these DOF controls, we can also use the mouse to capture one of the axes of movement, as in here, and just move it by dragging it with the mouse. Okay, and finally we can also move it by moving the compass, which may be attached in this case to the tool frame of the robot or to the end of a manipulator. And we can move it in various ways, along planes, along axes, or just using the point of the compass. And it uses inverse kinematics to solve its movements, and in this case we found an impossible condition. So we'll look in a short while at placing end effectors onto robots.